Hello. In today's video, we'll implement the three-part handshake the master and the slave node do, but from the master's perspective. So the first part of the handshake is the ping. The slave pings the master, and the master must just return a pong, and we already have implemented support for it right here. The next part of the handshake is the REPLCONF command. The slave sends the master a REPLCONF twice. Uh, the first, when it sends the REPLCONF first, the slave sends its listening port in this format, the port that it's listening on, and then it sends its capabilities to the master. It's just letting the master know what are its configurations. That's what the meaning of REPLCONF is. That's what it stands for. So the slave sends these two things to the master. We'll add support for this in this video. So let's get going. Okay, first of all, let me see. Yeah. So in the last video, we created a master TCP server and a slave TCP server. So for any new command that we add, we need to add the case for it in both the classes. That's unfortunately how it's going to be. And that is because the slave and master, they react differently. They have different behaviors. And so we should have this switch case in both classes. Most of the commands will behave similarly, but some will behave differently. And for that, like the set command in the slave, the set command is not processed. We return an error. And so because of this behavioral differences, we have created two classes. The next thing I want to get at is in a previous video I had created this infra package and it was outside of my components package because the client is not a component. But now we need to store the clients and the slaves in lists or rather hash sets because soon we'll need to iterate on them. For instance, if I have to send a command down to all the slaves, then I need to iterate on all the slaves. And to be able to iterate on all the slaves, I need to have a pool, a connection pool of all the clients and the slaves. And hence, I'll call that class a connection pool. But I need an instance of it. And I need it injected via the dependency inversion container, IOC container. And so since all my beans are in this components package, I'll move this infra package to the components package as well. I'll refactor, and in the infra package, I'll create another Java class called a connection pool. All right. And since it's going to be a bean, I'm going to annotate it with a component. And my connection pool is going to have two sets. It will be a set of client and I'll call it clients, and I need to also store all the slaves, but wait a minute, slave, but we don't have a slave class yet, right? We only have client, and we need another class that will represent a slave, and it's essentially going to be a client but with additional properties. So I'll just no skip. I'll just copy and paste the client and rename it to slave. And in the slave class, instead of all this, I can just keep a client, kind of like a one-to-one relationship, and I don't even need the ID here. I can simply place the client right here, like so. And in addition to client, instead, let's call it connection. And as we said, the second part of the REPLCONF command is actually the capabilities that the slave has. It only has PSYNC 2 capability in our particular build your own Redis from scratch challenge, and but we'll add a list to store all the capabilities as well. Public, yeah, list of string. capabilities. I hope the spelling's right. And in the constructor, it's going to take a client, and that's it. Because we'll populate the capabilities later on. But I'll initialize the capabilities with a empty with a new array list. So this dot connection equal to client and this dot capabilities new array list. All right, we'll populate this list in the PSYNC 2 phase, which is the next phase of the handshake right here. We'll do that when we go ahead with that stage, but that's not going to happen right now. So that's it with the slave. Don't need to make any changes. It is slave, I think so. I'm pretty sure. All right. Yeah, that seems fine. Now back to the connection pool. Now my connection pool needs a constructor and it needs getters and setters. So let's generate getters and setters, and I just need getters, not the setters. Generate getter for all right, and I need constructor as well. Yeah, the constructor will have nothing. All right. In the constructor, let's move it up. And let's move the constructor up as well. In the constructor, I need to initialize the clients and the slaves with a new hash set. And I need functions to add clients and slaves to these hash sets and to remove them. So, did I make, yeah, public add client. It takes a client. And what it does is I'll check if the client is not equal to null. I will add to clients.add client. And since I'm not returning anything from this method, it's going to be a void method. Similarly, I'm going to have a add slaves method. Add is going to take a slave, and if slave is not equal to null, I'll add the slave. All right. Now I need methods to remove the clients and the slaves as well. Just the basic stuff. Public boolean remove client. It takes a client. I can also take an ID and remove on the basis of ID, but oh well, let's just take the client. And that'll be clients star remove client, and similarly a remove slave method, and I can just return what's the error here is already defined in connection pool. Okay, yeah, right here. I'll rename it to and it removes the slave instead. And now just think about it a little. My slave has a client. It's a one-to-one relationship and a unidirectional one-to-one relationship. So can I remove slaves on the basis of client? Yeah, we can. So let's just add that as well. Remove public boolean, remove slave. But instead of taking a slave, it takes a client. If my client is promoted to a slave, I can't remove a client. I need to remove it from the slaves hash set. because when I promote a client to be or rather demote a client to be a slave, the connection will be moved from the client's hash set to the slaves pool hash set, whatever. And so yeah, we need to remove from the slaves hash set on the basis of client as well. I need that capability. So how can we do that? I need to have a slave to remove variable, and I'll iterate on the slaves, and if s dot connection dot equals what client, then slave to remove equal to s, and we can break out of the loop. All right, and we can simply return slaves dot remove slave to remove. Why doesn't it work? Might not have been initialized. So let's just do that. And I think all the methods are completed that we need for the connection pool. And okay, so let's start adding the switch cases that I talked about before in the master and the slave. So here I need a switch case for REPLCONF and here as well. Why do we need it here? Because my slave can act as a master to other slaves, and it can be a chain of slaves distributed across the globe. From anywhere I can hit them, and for efficient caching I need slaves to act as masters as well. So that's why we need it in both the classes, and instead of info command, let's call the REPLCONF command. Now, as I said, whenever I receive a slave, I'm going to promote or demote this client to a slave, right? And that can only be done if I pass it down to the command handler. I'll do the promotion demotion in that method, not right here, because then I'll need to do it in both the classes, and I'll generate this method in command handler. All right. So the REPLCONF method, now I don't have error in both the classes. I can close them. The command handler, all right. In the command handler, I'm going to demote this client from the client's hash set and add it to the slave's hash set. But to be able to do that, I need to auto add the connection pool. Auto add public connection pool, and here I can do connection pool dot remove. I think so. Yeah, we created those methods, right? Yeah, and then here I need to remove client. Yeah, because as soon as I get, I need to remove, but it might not be there. So wait, switch, because my command will have the listening port and the capabilities as well, and I need to parse them, right? So I can do command of 1, and the possible values are let's just copy it to prevent misspellings. It's listening port, and here I can break And here the next other thing it can be is kappa, right? Yeah, kappa. All right. So when I get into listening port, that's the first handshake that will be sent by the slave node. So I can remove the client from the client's hash set in this case. And let's just do that now. Connection pool dot remove client, and I'll remove the client. I'll create a new slave, and we'll take a client, and I can add it to my connection pool dot add slave. Yeah, I'm not. Yeah, that's it. But what does the listening port return? I forgot to see that. It expects an OK back. So let's just copy that. Instead of break, I can just, can't I? Return like so. All right. That should work fine. Yeah, that seems about right. And what does the kappa do? In the kappa, I need to populate my capabilities, but I need to find the slave as well. Now, what we did right here, connection pool, where is the connection pool? I need to find the slave by client, but instead of slave to remove, it's slave. Let's just call it slave. Uh-huh. Let's just call it this, and instead of here, it's going to be connection pool dot get slaves, and I'll iterate it, and if I find it, I'll store it in slave, and I can break out. Now here, I need to add its capabilities. Excuse me. So to do that, I need to iterate on the commands array. And if I find a capability, I can add the next element to my capabilities. For vanity I equal to 0, I less than 1.length I plus plus, and if command of I dot equals, it can be equal to kappa, then I can slave dot capabilities dot add, what can I add, the next element in the commands array, and it returns an OK as well, right? So I can simply return an OK right here and remove the break. All right. Huh. I need to add a return statement. So let's just return an OK right here as well, outside the switch case. All right. I think the REPLCONF is fine now. Let me see. Let me check. I have added this. I have added the kappa, the listening port. I auto-add the connection pool. I didn't change anything here. I changed REPLCONF here. Let me see. All right. Yeah. Handle. Yeah. So I haven't added anything to my client's hash set yet. If you think about it, I just removed from it, but I never added to it. And I think I'm creating the clients in my, yeah, right here. So I have a client here, right? So I can add it to the connection pool, but I need to auto add that as well. So wired private connection pool dot add client, and when I get out of this while loop I can remove the client. Remove client and client. But what if my client was demoted to be a slave? Then I need to remove it from the slave's hash set as well. Remove slave, and we have already implemented where we are removing a slave based on the client, and we can call it right here. And I think we need to do this in both the classes, the slave and the master both. So let's just copy it, and I'm going to paste it right here. But I need to auto-wire it as well. So let's just copy that as well. I paste it right there. Uh, yeah, so I've added to the clients. I've removed from the clients wherever required. I've added to the slave and removed to the slaves wherever required. We created a slave. We edited, but uh-huh. I think that's all we need. Let's try and push. What is the stage called? It is called FJ10, FJ0. It's running our tests. Let's see what we get. So it all works. You're good. All right, so the test's passed. Okay, we can move on to the next stage. But before moving on to the next stage, let's discuss something. So my slave connects to the master. It sends a ping and it sends a REPLCONF. Once the REPLCONF is received and once the handshake is completed, my master needs to send down messages to each slave. And to do that, we'll need to iterate on every slave in our connection pool. So we have it right here. And whenever required, we can get this set from my connection pool and we can iterate and send whatever commands we are receiving. Right, handle client, handle command. Yeah, whatever command, whatever write command the master receives can be trickled down to each slave. So basically what I mean to say is for slave s in connection pool.get slaves, we can s slave.send, we'll create that method soon enough, and we'll send the command down to the slave nodes as well. And that's what we'll be doing in the next stages: single replica propagation and multi-replica propagation. And here there will only be single replica, single slave, and we'll send down command. But when multiple replicas are required, so we would have needed to save them in a pool, and we have added support for that already. So I'm pretty interested to solve these stages. I hope you are too, and I'll see you in the next one.